Hey, we have a problem from the 2021 AMC 12B. This is number 10. Two distinct numbers are selected from the first 37 positive integers. The sum of the remaining 35 is the product of these two numbers. Okay, so we have this portion is equal to this portion. Let's see if we can express that. Sum of the remaining 35, we don't really know what the two numbers are, so that might be a little bit difficult. So what I'm going to do is call these two numbers m and n. And we can just say the remaining 35 is the sum of all of them minus m and then minus n. So we want to find out what this total sum. This is just the sum of the first n numbers. That would be 37 times 38 divided by 2. That's 37 times 19. And that is 703. So we're going to have 703 minus m minus n. That's this. And the product of these two numbers, that is m times n. Okay. So, how are we going to solve this? Well, we know m and n are one of the numbers from 1 through 37, so that limits us a little bit. What could we do with this? The first thing, let's see if we can remove the m and the n on this side and see if we can do something about it. Maybe we can factor a little bit. N plus 1 plus n. Well, you see this is n plus 1 and this is n, and that looks pretty close. We just add a 1 on this side and add a 1 on this side, then we have n plus n here. So then we can factor out that 1. Factor out the n plus 1, we have n plus 1 times n plus 1. That equals, this is 704. So now let's look what happened here. We have an integer plus 1, so this is an integer. And we have an integer plus 1, so this is an integer. So the product of two integers makes 704. And that's a lot easier to deal with because this has a bunch of factors. It has 2 times 352, 2 times 176, 2 times 88, 2 times 44, 2 times 22, and 2 times 11. So we have 1, 2, 3, 4, 5, 6. This is 2 to the 6 times 11. And now our choices are limited because there has to be a total of 6 factors of 2, and there has to be a factor of 11 in either one of those. Okay. And how do we get there? We had an mn, an m, and an n, and we just stuck a 1 here. That's how we did that. And this trick right here is Simon's favorite factoring trick. You add a little extra term on the end so that we can factor it easier. You can also do this if you have something like mn plus 5n plus n or something. If you factor out the n, you see you have an n plus 5, so you want to make a n plus 5 on this side. Plus n plus 5, and of course, you'd either have to put a minus 5 to cancel it out or put it on the other side of the equal sign. So this would make n plus 1, n plus 5, and you can go that way too. But anyway, so we have n plus 1 and n plus 1. It has to have 6 factors of 2 and a factor of 11, and it has to be one of these numbers. So let's see what we can do here. Well, 11 works, so what if we set one of them to 11? It's 2 to the 6. Well, that's 2, 4, 8, 16, 32, 64. 64 is too big. So let's move one of the factors of 2 to this side. So this is 22, 32. Both of those work because both of them are in here. So now we just need to figure this out. If m plus 1 is 22, then m must equal 21. If n plus 1 is 32, m must equal 31. So what is the difference? 31 minus 21 equals 10. Now, the only reason this worked is because m and n were restricted to only integers. If they could be any real number, like if they could be like square root of 2 or 1.5, well, then this could really be anything. You could have like, I don't know, square root of 704 times square root of 704 if you wanted to. Or you could have like 3 and 704 over 3. That would be valid as well. The only reason it's restricted so much is because they have to be integers. And that's why this trick can sometimes be useful when you have integers.